All right, guys, in this problem, we are given this degree 5 polynomial, and we are asked to find all of the roots, or the zeros. We're given one. We're given that one of the roots is the complex root 3i. And so, given one, we want to find the other 4. There are 5 roots in total. Some of them will be real, some of them will be complex. We're asked to find all 5 roots. Okay, well, from the conjugate root theorem, we know that if the root 3i, if 3i is one of the roots, then it follows that another one of the roots is negative 3i. All right, so we know right off the bat that if one root is 3i, the other one must be negative 3i. That is the conjugate of 3i. So because the root is 3i, it follows then that the factor is x minus 3i. It's one of my factors. That's from that first root that we're given. And that the other root is negative 3i, then the associated factor there is x plus 3i. So I have these two factors. These are two of the factors of my polynomial. What I'm going to do is I'm going to multiply them out together, and then I'm going to divide that into my full polynomial. So foiling it out, I get x times x is x squared. X times 3i is 3i times x. Negative 3i times x is negative 3ix. And then finally, negative 3i times 3i is negative 9i squared. I have some cancellation. I have 3ix minus 3ix will cancel. And then I am left with x squared minus 9i squared. But by definition, I squared is equal to negative 1. And so this is x squared minus 9 times negative 1, which is x squared plus 9. And so I have the quadratic x squared plus 9. That is a factor of my polynomial. So what I'm going to do is I'm going to divide that in. X squared plus 9, I have this right here. I'm going to divide this into my polynomial. So I have x squared plus 9, dividing this in. All right. How many? X squared goes into 2x to the 5, 2x cubed times. 2x cubed times x squared is 2x to the 5. And 2x cubed times 9 is 18x cubed. And I'm going to put that here. That's 18x cubed. I want to have like terms above and below one another because I can only add and subtract like terms. And so now I will subtract. I will get 0. I have negative 3x to the 4 minus 0, so that's minus 3x to the 4. And I have negative 5x cubed minus 18x cubed, so that's going to be minus 23x cubed. And I'm going to bring down my next term, that is negative 15x squared. X squared here goes into minus 3x to the 4 minus 3x squared times. So that is minus 3x squared. Minus 3x squared times x squared is minus 3x to the 4. Minus 3x squared times 9 is minus 27x squared. So that is minus 27x squared. And I'm going to put it here underneath the minus 15x squared, again for that same reason. I have to add and subtract like terms. I will subtract, I will get here a 0. I have negative 23x cubed, subtract 0, so it's just negative 23x cubed. And I have negative 15x squared minus negative 27x squared. That's a double negative, that's a positive, so that is minus 15 plus 27, which is positive 12x squared. X squared goes into minus 23x cubed minus 23x times. So that's minus 23x. Minus 23x times x squared is indeed minus 23x cubed. And minus 23x times 9 is, let's say, oh, I actually forgot. I need to bring down my next term, minus 207x. I'm sorry about that, minus 207x. So that I have somewhere to put this, minus 23x times 9 is negative 207x. Minus 207x, that's what reminded me of it right there. So it's minus 207, and now I subtract. I get, here is 0. 12x squared minus 0 is, I have 12x squared. Minus 207x minus negative 207x is, I have 0x, and then one more time I bring down my last term, that is plus 108. And finally, x squared goes into 12x squared 12 times. So I have plus 12. 12 times x squared is 12x squared. And 12 times 9 is positive 108. And now when I subtract, I get 0, x squared. I get 0x minus 0, so I get 0x, and I get 108 minus 108, so I get 0. So I have a remainder of 0, showing that x squared plus 9 is indeed a factor. And of course, it also means then that 2x cubed minus 3x squared minus 23x plus 12 is also a factor. Let me convert this. And bring it down. So this is now my cubic. This contains the other three factors that I'm looking for. So I need to factorize out this cubic. To do that, I'm going to use the rational roots theorem. So the rational roots theorem tells me that if I designate this here P and this here Q, then if this function has any rational roots, then they will be factors of, they will be in the form P over Q, where P are the factors of 12 and Q are the factors of 2. So they will be in the form P, 12 has factors plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Those are the factors of 12. Q, that's my leading coefficient 2. Well, 2 is a prime. It has factors plus or minus 1 and plus or minus 2. And so my options then for my factors, for my potential rational roots are plus or minus 1, plus or minus 2, that's plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 3, plus or minus 4 over 1, plus or minus 6 over 1, plus or minus 12. And then I can also take plus or minus 1 over plus or minus 2, so that's plus or minus 1 over 2. Note that plus or minus 2 over 2 is the same as plus or minus 1. I have plus or minus 3 over 2. Plus or minus 4 over 2 is the same as plus or minus 2. Plus or minus 6 over 2 is the same as plus or minus 3. And plus or minus 12 over 2 is the same as plus or minus 6. So this is it. These are my potential rational roots. I use trial and error then to find the actual root that I'm looking for. I'm going to start with my fractions. As a matter of fact, I'm going to start with these ones rather than the integers, just to check those ones first. You can start with the integers if you like. So I'll try plus 1/2. So what I'm going to do is I'm going to substitute positive 1/2 into my cubic, 2x cubed, and I'm going to see if it is indeed a root. If it is a root, my cubic will be equal to 0. So that will be then 2 times 1/2 cubed minus 3 times 1/2 squared minus 23 times 1/2 plus 12. 1/2 cubed is 1/8, so I have 2 times 1/8. Minus 3 times 1/2 squared is 1/4. Minus 23 over 2 plus 12. 2 times an eighth is 2/8, that's 1/4. Minus 3/4. Minus 23 over 2 plus 12. I want to add all these together. I might consider taking a common denominator. A common denominator of 4, 2, and 1 is, of course, 4. And so I will get 1 minus 3 minus 2 into 4 is twice. 2 times 23 is 46. Plus 1 into 4 goes 4 times. 4 times 12 is 48. And so if I add up my numerator, I get 1 minus 3, that's minus 2, minus 46. That's negative 48 plus 48. And sure enough, that is 0 over 4, which is 0. And so 1/2 is indeed another one of my zeros. X equals 1/2 is indeed another one of my zeros. So I now have a third zero. I have the zero that I was given at the beginning. That was 3i. I have the used the conjugate root theorem to find minus 3i. And now I have used the rational roots theorem to find another zero. That is x equals 1/2. And so what I can do is I can now find the factor. X minus 1/2 is equal to 0. And so multiplying across by 2, I get 2x minus 1 is equal to 0. And this 2x minus 1 is another one of my factors. So what I'm going to do is I'm going to take my cubic here, and I'm going to divide it into x minus 1 into it. So there's my cubic. And into that, I'm going to divide 2x minus 1. Almost there. 2x goes into 2x cubed, x squared times. X squared times 2x is 2x cubed. And x squared times negative 1 is negative x squared. I will subtract. I get 0. Minus 3x squared minus negative x squared is positive, so that is minus 2x squared. I bring down my next term, minus 23x. 2x goes into minus 2x squared, negative x times. So I get negative 2x squared. And then I have negative x times negative 1. That is plus x. I subtract. I will get 0. Negative 23x minus x is negative 24x. And then finally, my last term, plus 12. 2x goes into negative 24x, negative 12 times. So I have here negative 12. Negative 12 times 2 is negative 24x, and negative 12 times negative 1 is plus 12. When I subtract, I will get 0x plus 0, showing that 2x minus 1 is indeed a factor. And of course then, just to finish it out, x squared minus x minus 12. This here, this quadratic. Oops, let's go back. Let's not convert that in that case. It doesn't want to be converted right now. X squared minus x minus 12. X squared minus x minus 12. I'm going to let this equal to 0. I'm going to factor it and solve it if I can. I think I can. So I have factors here. If it didn't factor, I would simply use the quadratic formula. X and x, I have a negative 12, so that means that my signs will be plus and minus. And I think it's going to be 3 and 4. 3x minus 4x is indeed negative x. And so I'm good. By the zero product property, x is equal to negative 3. and x is equal to 4 are my two solutions. Those are my other two zeros. And so finally, I have now all of my zeros. I have all of my roots, zeros, and they are x equals 3i, x equals negative 3i, I have x equals 1/2, x equals negative 3, and x equals 4. And so indeed, this particular polynomial did indeed have three rational roots, 1/2, negative 3, and 4. So it has three real roots. These roots here, these are real. These are the values. This is where our function crosses the x-axis. It crosses at x equals 1/2, x equals negative 3, and x equals 4. And these here are my complex roots. So these are complex 3i and negative 3i. But I have found all 5 of my roots, or all 5 of my zeros, which is what we were asked to do. I have graphed my solution down here using Desmos. And you see that indeed our function does cross the x-axis 3 times at negative 3, 0.5, and 4. And note that the end behavior, it's in degree 5 polynomial, so it's odd degree, so it rises on one side, falls on the other. The leading coefficient being positive, it rises on the right and falls on the left. And that is that problem complete.